The physical properties of alcohols, by right you should remember it. So alcohols are soluble in water, but their solubility decrease as the molecular size increase. That means as the number of carbon increase, it will become less soluble. So as explained over here, you see if you have methanol with water, you'll just dissolve as in the diagram. So then if it's butanol and water, you will see that it is only slightly soluble, then you have one layer accumulating on top.
So all are soluble in water, but it decreases as
Solubility decreases.
Okay.
So that means right, only the first few is soluble, then after that it's gonna be lesser and lesser soluble. Like this case. But you only need to know 4 lah. If they ask you for more, that means they will only ask you in terms of naming. That one is you can do up to hexanol and all that. That means it's just 6. Heptanol means 7. But the characteristics, the properties, and the physical state and all that, they will only ask you up to 4 the most. Then all hydrocarbon and alcohols, right, they will be able to burn in oxygen. So combustion takes place. Yeah. So combustion takes place and the alcohol will burn with a clean flame or blue flame without soot. Why?
Because it's complete combustion.
No. Complete combustion will sometimes you will also get, if you compare, or rather it's more like higher chance of getting complete combustion because your alkenes, you also have complete combustion, but sometimes they produce soot also. So if you want to compare, it's actually like this: alkene, and then alcohol. So alcohol has the cleanest flame probably because it has the lowest percent carbon. So you can go and calculate the percentage carbon of alkene, and alcohol, right? You will see that this one is the cleanest. I think this is the second because the percentage carbon is low also, but higher than the alcohol. Then I think this one has the highest percentage carbon. So this alkene will burn with the sootiest flame. So they will ask you for equations. So I will just run through one. Then after that, the rest is the same because I assume now the balancing equation is okay. What is the formula for ethanol?
Formula for ethanol is C2H5OH.
Okay, so plus oxygen gives you carbon dioxide and water. So like that. Okay, so 2 here, then 5, 6. So 3. Then you got 4 plus 3. 4 plus 3 is 7. So 7 minus 1, 6. Like that. Is this balanced?
Wait, the O2 got 2. There's 7 O on the left, only 5 O on the right. So must
5 O meh?
5.
Down here got 4.
7.
Down here got 3.
Yeah.
Okay, anyway, the answer is like that. Right.
Right.
So you can go and try this on your own later. Answer provided. Question 3. What yours?
Is this steam and carbon dioxide?
Yeah, because what happened is like this: in combustion, right, you are likely to produce energy, then the temperature may be high, so you either get water, which is in liquid state, or you get steam, which is like water vapor. Then if it's incomplete combustion, right, then it will be carbon monoxide and water, or it may be some other combination of product, maybe soot. So then we have chemical properties of alcohol. That means what kind of chemical reactions alcohol will go through. So alcohols can go through, just now there's one which is combustion. Second one is oxidation. So when alcohol is oxidized, it will become a carboxylic acid. So the number of carbons remain the same. The only thing different is the number of hydrogen and number of oxygen will be different later. Before and after. So oxidation can happen in 2 ways. One, by bacteria in the air. So if there's oxygen and there's the bacteria in the air, you will get oxidation. So the bacteria is somewhat a catalyst. Then the second case is by using oxidizing agents. So you have in your redox reaction, you will learn there's potassium manganate 7, which is the one that is from purple to colorless. Yeah. So then there's also a acidified potassium dichromate 6, which is the orange to green or green to orange. Yeah. So you have these 2. So theoretically, right, you can use any oxidizing agent. It will cause the alcohols to become carboxylic acid. So you don't panic if there's a question on alcohol and the oxidation alcohol, but you don't see oxygen, you don't see potassium manganate 7, you don't see potassium dichromate. That means the question should have another oxidizing agent somewhere.
Yeah. Okay.
So don't fret. So if it's using, okay, let's say ethanol. So what happens is, you see the equation down here, you get 2 oxygen and then the ethanol become ethanoic acid. So what it does is you have the ethanol here. Now this is quite technical. You have the ethanol molecule here. When oxidation takes place, the carbon, right? You go to the carbon next to the OH. Then you pull out the 2 hydrogen on that carbon and insert the oxygen there. So then you have 2 floating hydrogens out that came out, right? So these 2 hydrogen will then connect with another oxygen here to form water. That's how you get this equation.
Yeah.
So if they ask you, say, okay, I have propanol and then I react it with oxygen, then what happens? Then you do the same thing, which is, so you go to the carbon next to the OH like that, then H2O. So this method works for any alcohol if you want to do oxidation alcohol. Can I move on?
Yeah, can.
Okay, oxidation ethanol with the oxidizing agent. Okay, so in this case, right, this is the same thing. It just tells you that the dichromate is orange and then it will turn into green color. So if in your case, right, you're using manganate, potassium manganate, right, then it will be this reduced to this, and then the color change is purple to colorless. Oxidizing with what is the formula for the compound after ethanol is oxidized? What is the answer?
After ethanol is oxidized. The first one is
ethanol.
The first one is ethanol, but
that's why it's ethanol.
But then it's after oxidized is
after ethanol is oxidized. So ethanol gets oxidized to acid. Right. Just now we
yeah,
say,
so it's B. Is it B? C.
Is it B? Is it B? What is B? Draw out, you'll know. If you
It
draw,
is, right?
you'll know. The B, right, is CH3OH. This is an alcohol.
Oh, wait, wrong.
Wrong number. Next. I tell you, draw out, you will see it.
It should be C, right? C.
So the number of carbon before oxidation and after oxidation will be the same.
Then the only thing that changes or nothing changes.
Just now you say, right? I draw out the ethanol. Then you want to do oxidation. That means you go to the carbon next to the OH. Then you take out the 2 hydrogen from there. Then the 2 hydrogen come out. Then just now I took out that the hydrogen from the carbon already. I replace it with 1 oxygen. Then another oxygen will go to the other 2 hydrogen, then form water. So this is CH3 because this is CH3. Then COO, so COOH. So what is written here is they combine these 2 oxygen and write like that.
Okay, so they took out.
So the question was purposely made such that you know whether you took notice of the number of carbon is the same. And to also figure out whether you can tell alcohols and carboxylic acids apart.
So the 2 hydrogen that came out then will be times to the oxygen, is it?
The 2 hydrogen that come out will go to 1 of the oxygen. Then the other oxygen will go into to replace the 2 hydrogen that came out. So you end up having this.
Okay, can.
It's made to cheat your feeling one.
Yeah.
So if you don't take notice, right, don't look at the structure properly, right, or you don't draw it out, right, you will overlook and then
Which one is B?
Yeah, it's quite giveaway.